So this is our project. We opened our project, and now we're gonna be looking at some of the codes that we have. So if we go into scripts folder, we're going to be seeing two scripts or two C# classes or two components, whatever you want to call it. But we are gonna call it components, okay? Because we're gonna be talking in terms of Unity project. So the first script is environment script, and this is the script that's going to be responsible for resetting the environment every time an episode ends, as well as the rotation. Yeah, okay. So the main script or the main component is going to be this one, Cuckoo Car Agent Park. This script is basically what's driving our car and basically what's allowing our car to act as an agent. So it has a bunch of things that it needs to do. First is going to be getting observations. It has to observe its environment and the world. So we have to set that up, and secondly we have to set up the actions. We have to define actions and how those actions are gonna influence our agent. For example, moving forward, backward, left, and right. Those are the actions, and we have to define those actions. Thirdly, the most important one is, and the most tricky one as well, is going to be the reward system. We have to set up a reward logic that's going to be good enough so that the agent is not going to exploit it, and it's going to help the agent to learn maneuvering the environment and reach its target successfully. So after a lot of trial and error and training, I came up with a somewhat decent reward system, I would say, for this specific project. So I have divided this code, I have divided my code into different sections, and where we are going to be looking at this from a flowchart perspective, starting from the top to the bottom. So it's going to start from the start of the life cycle, and we're going to stop at the end of the life cycle. So the first function that's going to be called is going to be the start function, and this is going to be called by Unity. And what we are going to do in this function is we're going to set the values for the car controller, the rigid body, and the sensor. We do this by calling the get component function that's going to be supplied to us by Unity itself, because our Cuckoo Car agent is the child of agent, and agent is the child of mono behavior. So and mono behavior is a class that's supplied to us by Unity, and it contains all of these functions. So once that's done, we are going to be collecting our observations, and this is the function that's going to get called. So the observation that we collect are pretty basic because we want it to be very realistic, and that's what we tried to do right here. So the first observation data that it has is the speed of itself. So it's gonna be observing the speed that the car or the agent is currently moving at. And the second one is gonna be the relative position of the target that it has to reach. In our case, that's gonna be this parking spot. So we get the relative position of the parking spot by subtracting the position of the parking spot from the position of the agent, and that will give us the relative position of the parking spot. Once we have that, we're gonna set it as another observation. And unlike the current speed, the actual value of the this observation is going to be four numbers, because speed is a float value, right? But when it comes to position is not a float value. It has x, y, z axis. So it's going to be three numbers. And then we also, the third observation is going to be the rotation of the agent itself. So this rotation, that's going to be the third observation. And it's going to be four numbers. It's going to be x, y, z, w, pitch, yaw, roll, and quaternion. And the fourth and final observation that the agent is going to be having access to is going to be the target's rotation. So this parking spot, its rotation. So those were the observations. Now we're going to be looking at what's going to happen after a certain interval of time. So this is this function. It's going to be called after a fixed number of interval of time continuously. So it's going to be in a loop and it's going to keep getting called over and over again after a certain amount of time has elapsed. And this is going to be called by our parent class. That's going to be our agent, so we don't really have to worry about this. We just have to make sure that there's a decision maker component attached to our agent. Okay, so it is gonna have action buffers as its parameter, and what we do is we are keeping track of the action taken, and and if the number of action that we take has exceeded the max step, or if it has reached max step, we're gonna run this calculate actions taken reward function. This is going to basically reward the agent based on how many action it has taken. And and then we are going to be storing the values from the continuous actions array. So your agent is going to be able to take different actions, right? For us, it's going to be 3 actions, and we are going to be storing them in this continuous actions. So the first action is going to be the steering. So basically the rotation. This is going to be the first action, and it's going to range from -1 to 1. That is the reason why we set it as continuous action. The second action that it's going to be able to take is acceleration. That's going to be how much it's going to accelerate. The third one, third action that it's going to be able to take is going to be the reverse action, and that's going to determine how much braking power or how much backward your car is going to move. Okay. So once we set up these actions and do some calculations, we're going to use our car controller object and call the move function and pass these 3 variables. And that's going to allow our agent to move freely in the environment, and that's how we translate the actions that's being passed by this function into our agent and allowing it to move. Okay, and once we're done with moving the car, we are gonna calculate the reward and add the reward, and we are going to check if our car is almost parked perfectly. If it is parked perfectly, then we are going to end the episode. But before we do that, we are gonna reward the agent by adding 1000. Yes, that's 1000 points. And then we are gonna just call the reset script. I don't know what the hell this is actually, because it's been a while since I did this project, so I don't know what it does. But yeah. And yeah, that's it. Now we are gonna be talking about the main component. That's gonna be the reward function. So we have a couple of reward system setup. The first one is gonna be rewarding the agent based on the distance. So whenever the agent reaches a new closest distance to the target, we are going to be rewarding the agent. That's basically what this one is doing. This function's doing. The second one is we are going to be penalizing the agent every time it doesn't move. So this encourages the agent to keep on moving, because if it doesn't, we're gonna be penalizing it by 1. And then we have calculate actions taken reward. This is going to reward the agent for taking the least amount of actions to complete its goal, which is going to be reaching the target location and parking in a good angle. And then we have calculate parking reward. This is going to get triggered only when our agent is within the parking spot. So over here. So when we are inside the parking spot, we are gonna be rewarding the agent based on the angle it's currently parked in, and compare that to the rotation of the parking spot. So we are basically getting the delta of the rotation between the agent and the parking spot, and we are using that to reward the agent. Apart from this, we are also going to be checking this function right here. This function is going to return true or false, and it's called is close to perfect position. This function is going to return true if the rotation delta is within a certain threshold for it to be considered a success. For example, if the delta is going to be huge, for example, the car is parked this way, then it's going to return false because the delta rotation between the agent and the car is way too high. But if it's parked this way, then, or let's say this, then the delta rotation between the car and the parking spot is very less. So we can consider that the car has been parked perfectly and we are going to be returning true. So when it returns true, we are basically going to be ending the episode by rewarding the agent hugely because it was able to park almost perfectly, and that's gonna keep on encouraging the agent to keep to try and park as perfectly as possible. Yeah, so that's how this agent script works. And then we have some on collision enter function setup that's going to be penalizing the agent whenever it hits a wall or an obstacle. Yeah, yeah, so that's it. My head isn't really working because it's currently 7 a.m. and I haven't slept yet. I have been working on some of my other projects, and I decided to just make a video for this project as well. Yeah, so that's gonna be it. Good night, guys. I'll see you later.